Hello students, a very warm welcome to a lecture series of Principle of Electronic Communication. Let's understand basics of communication system first, in which we need to discuss about the EM wave spectrum. E stands for electro and M stands for magnetic. Now spectrum is a band of frequency. Summing up this, the electromagnetic spectrum is a range of all type of EM radiations. The types of EM radiation that make up the electromagnetic spectrum are visible light, radio waves, microwaves, infrared light, ultraviolet light, X-rays, and gamma rays. Uh, this is a diagram in which you can see the names radio, microwave, infrared, visible, ultraviolet, X-ray, and gamma ray. This shows that gamma ray has maximum frequency and radio waves has minimum frequency in EM wave spectrum. Let's understand which kind of all these waves are and where they are used. First of all, radio waves. You know that your radio captures radio waves emitted by radio stations, bringing your favorite tunes. Radio waves are also emitted by stars and gases in the space. Microwave radiation will cook your popcorn in just a few minutes, but it is also used by astronomers to learn about the structure of nearby galaxies. Infrareds are used in night vision goggles. It pick up the infrared light emitted by our skin and objects with heat. In space, infrared light helps us map the dust between stars. Visible rays. Our eyes detect visible light. Fireflies, light bulbs, and stars all emit visible light. Ultraviolet radiation is emitted by sun and are the reason skin tans and burns. Now X-rays and gamma rays both are used in medical field. A dentist uses X-rays to image your teeth. An airport security uses them to see through your bag. Doctors use gamma ray imaging to see inside your body. And the biggest gamma ray generator is the universe. Electromagnetic radiation can be described in terms of a stream of massless particles called photons, each traveling in wave-like pattern at a speed of light. Each photon contains a certain amount of energy. The different types of radiations are defined by the amount of energy found in the photons. Now, what is the connection between waves and photons? Let's see. Radio waves have photons with low energies. Microwaves photons have a little more energy than radio waves. Infrared photons have still more than visible, ultraviolet, X-rays, and the most energetic of all is gamma rays. Now, how we can measure electromagnetic radiation? Electromagnetic radiation can be expressed in terms of energy, wavelength, and frequency. Frequency is measured in cycle per second, which is hertz. Wavelength is measured in meters, and energy is measured in electron volts. Each of these three quantities for describing EM radiation are described to each other in a precise mathematical way. Now look at this diagram. This diagram shows us that radio wave has the minimum frequency and maximum wavelength, and gamma rays has maximum frequency and minimum wavelength. Also we have a mathematical equation through which we can correlate the wavelength and frequency with each other. Wavelength and frequency are reciprocal to each other. see the equation at the bottom of the slide, in which the left hand side of the equation is called lambda. The right hand side has numerator and denominator. Numerator is speed of light and denominator is frequency. So this lambda is wavelength, f is frequency. So frequency and wavelength both are reciprocal to each other. Means if the frequency increases, the wavelength decreases, and if the frequency decreases, the wavelength will increase. And the speed of light is described by 3 into 10 raised to 8 meter per second. So if we have wavelength, we can find out frequency through this equation, and if we have frequency, we can find out wavelength through the equation. So again, coming up to the same diagram, again you can now understand that if frequency is higher, then the wavelength will be the lesser, and the frequency will be lesser. If the frequency is lesser, then wavelength will be higher. Now see, this diagram shows that which type of EM wave has which kind of production, application, and life science aspects. And this table also includes the issues with any type of EM wave. So we have main radio and TV waves, microwaves, infrared, visible light, ultraviolet, X-ray, and gamma rays. Thank you everyone to watch the video till the end. I hope you all have got the basic insight of EM wave spectrum. Thanks for watching. See you soon for the next video.